Hi and welcome to another short video. My name is Torge Petersen from the Software PE group, and in this video I would like to show how to use the application log, also called the AppLog. I will show the AppLog component and guide, assign signals, and working with the application log editor to define the application log in combination with the assigned signals. After creating the application log and feed in some information, I will show how to read and store the log on your disk via the PLUS+1 Service Tool. Some Danfoss devices provide non-volatile memory. Application developers can use this memory to log machine event data and use the PLUS+1 Guide Service Tool to extract the logged data. The main use case of the application log is to store statistics on how your equipment is being operated and to gather data for troubleshooting certain parts of your system. The AppLog is not meant to log every event which happens in a system because the memory is limited and not high speed for logging. In this video, I refer to the application log functionality called Application Log 2, which uses the vector screen editor for Linux displays. The other application log functionality called Classic Application Log refers to the Classic Screen Editor and is not part of this video. If you are interested in that, you will find a very good description inside the guide menu. The component WriteAppLog instantiates an application log definition, similar to the probably more known component showScreen, which instantiates a screen definition. Via this component, you can draw and define what data gets logged, and you can set the size of the application log. As you can see inside the help, component WriteAppLog does provide more or less the same input and outputs like the component showScreen. A trigger input called enable, which must be true to log data, and a bus input for data signals from the application. The output bus does provide signals which has been assigned from the application log definition. Each WriteAppLog component that is used in a PLUS+1 guide project will result in the creation of one instance of an application log definition. You can add multiple WriteAppLog to your code and where you want inside the graphical guide code drawing area, the available memory size of your selected hardware will set the limit. As I already said, the component WriteAppLog is a hardware-dependent component for use with specific PLUS+1 hardware. This component only becomes available when you install the hardware HWD file for supported hardware in the Project Manager tab. PLUS+1 displays have either 2 MB, for example the DP200, or 60 MB for newer displays of flash full memory, also referred to as application logging memory. In the shown image, you can see that any PLUS+1 controller whose model number ends with a 5 or a B has the 2 MB of flash full memory. Like I showed before, the application log 2 editor is based on vector-based screen editor. The appearance of application log 2 editor is therefore similar to the appearance of vector-based screen editor, with just some little exceptions, which we will take a look at now. The design area is replaced with a screen area pane where the text to log are placed. The screen library only contains text and text lists. If the current HWD also supports screen definitions, then all text and text lists in the screen library are shared between application log definitions and screen definitions. And in addition, the properties of text and text list are different in the application log 2 editor and do not match the properties of a screen definition. The rest of the application log editor looks the same than the screen editor. On the top left, the screen manager listing the screen definitions and the input-output signals. Below that, the inspector to manage the properties settings, and on the right, the project library with the folders and elements, the preview, and the selector tab with the already mentioned 2 available elements, text and text list. I will keep the AppLog example for this video as simple as possible and took the AppLog example shown in the PLUS+1 Guide Advanced training session, but on a DM1000 instead of a DP700. First of all, I will connect all data that needs to get logged to the input bus of the component AppLog. First, I use a setPulse component to set the erase trigger, which deletes the AppLog from the memory. Second, I need some data, like in my case, an alarm number triggered via another parameter, and the real-time clock data to use these as a timestamp inside the AppLog. And last but not least, I need a trigger input to write the AppLog. So in this little example, the component set AppLog write is used to write data to the application log. Each time this parameter is set to true, an alarm number will increase so that different alarm numbers will be stored just to show the functionality of the application log. I used an additional trigger for the second data, so I added the setPulse component set AppLog write to as well. Inside the query dialog of the component AppLog, I select a new application log definition and add the inputs. That's all what is needed in Guide so far. Next step is to build the AppLog inside the application log editor. This can be opened via edit the component or edit definition inside the query dialog, or double click on the application log definition inside the project manager tab. After I open the application log editor, we can see that it has got a template screen, the so-called screen area pane. It does have a ready-made table with 3 columns. First column shows the icon of the 2 available elements, text or text list. Second column shows the description of the element, and the third column shows the text with the potentially assigned data. To this table, you can add as much text and text list elements you want. Anytime the write signal of the component is set to true, the text and the assigned data signal will be logged to the application log file. I'm going to log the alarm number and the timestamp. To do so, I first start to create a new folder in my project library. Then I create an alarm list consisting of 3 alarms. For each alarm, I create a text element with a fixed alarm text like alarm 1, 2, and 3. And these 3 single alarms are added to my alarm list component, where each alarm is represented via an index number. For the timestamp, I create a text component and build my own timestamp with a real-time clock signals year, month, day, hour, minute, and seconds. After creating my application log definition libraries, I can easily drag and drop each element into the screen area panel. The area where to drop the elements doesn't matter. It will be added automatically in the right order. Text elements will be first and text list elements are listed afterwards. At this point, the application log has been defined with 1 text element, including the timestamp year, month, day, hour, minute, and seconds, and the alarm list, including the active alarm number identified via the list index. The only thing we have to do in addition is assign the element signals with the input signals in the Inspector tab. But before we assign the signal, we will do some general application log settings. After selecting the object in the Screen Manager, the AppLog properties are shown in the Inspector and can be modified. Starting with the application log definition, in my example called alarms. First property entry is the file name. By default, the file name to have the same name as the AppLog definition. This name is used to store the application log on the controller storage in a CSV format, which can be read out later via the WriteAppLog function block, for example. For the functionalities shown in this video, it is useless, but I renamed it to AppLog 1 anyhow. Name is the name of the application log definition listed in the screen manager of the application log editor and in the project manager as application log definitions. This name is used for the AppLog component as well. I call it alarms. Via the port name, the memory area to use in the hardware unit can be selected. On my device, a DM1000 hardware, only flash drive is selectable. The size defines the memory size of the application log definition. It will be adjusted automatically to a multiple of the memory sector size in the hardware unit. So this size can only be set in steps of the memory's sector size, which is for the DM1000 display 262,144, which is nearly 256 kilobytes, and 2 times sector size will be 524,288 bytes. Property type defines the application data log as either circular or linear. With linear type, the log file will record until you are out of memory and further data gets lost. With circular type, the oldest data will be overwritten. This type requires minimum of 2 sector sizes of memory. I choose the type circular. Another property is delimiter, used to separate the fields in the output CSV file. The erase property can be used to erase the contents of the application log definition. For some hardware, the erase on download function is provided to erase all application logs on new application downloads. I assigned the input signal erase, which can be set via the parameter setAppLogErase. Save to file is a property in newer HWDs, which can be used to write the application log to an external storage via USB. My used hardware provides this property, but I keep it unselected for now, and we'll come back to this later in this video. And last but not least, the status property, which provides the current status of the application log definition instance via single bits like write, read, or erase is ongoing, end of file has been reached, or save to file has failed or is in progress. After setting the general properties for the application log, we will go to each text and text list definition, starting with the text definition date and time, which does include the timestamp with 6 data elements: year, month, day, hour, minute, and second, which needs to be assigned to the input signals. I will do this for each data value inside the date and time definition and assign the value signal. After assigning each value signal, we will have a deeper look to the properties of the definition itself, starting with the property assess to set the assess level of the data. This value works with the assess components to limit users' access to the application data log with the PLUS+1 Service Tool, followed with the property name of the definition and the tag property. The tag property determines which kind of access level the assess property will be compared to when reading the application log. It can be set to one of the categories E for error, S for statistics, or O for others. Please refer to the guide user manual for more information about these categories with the assess, writes, AppLog, statistics, errors, and others components. The next property, write, is probably the most needed one. It is used to start the logging of this application log definition. So here is a place to assign the write signal. In my example, I assigned the input signal write, which is set via the parameter setAppLogWriteTime. The pending signal can be read out to check the ongoing process of write. If pending is true, the data will be queued until it can be written. Now I have finished the setting for the first application log element, date and time. Next step, I will do the same for my second application log element called text list. Define or set the access number, the name, and the tag for this application log definition. The alarm list does include 3 single alarm text elements with their respective alarm text. Each alarm text element inside the alarm list is recognizable or selectable via the index number. So the text list property active index can be used to select any of the single alarm text element out of that alarm list via their list index. I assigned the input alarm number, which will be decremented via the parameter set AppLog write alarm between 0 and 2. At the end, we have the write and pending properties. In my example, I assigned an additional input signal write 2 to show you the independent between each application log element, and that each element can be logged apart. Each element triggered via its own write signal. At this point, the definition and setup of the application log is done, and I can compile and download the LHX on the DM1000 and check the behavior of the application log via the Service Tool. In Service Tool, I first download the LHX to the controller, so in my case to the DM1000 display. In the System Manager, I can go to my ECU under ECU list and open the application log folder and check the available application logs. There you can see that my created application log alarms is already listed in the flash memory. Via the link, you are able to read the application log from the memory and store it on your disk. But we will do this later because we know it is empty and we first want to fill it with some data. I create a parameter page, just a simple one, and add the erase and write parameter with the setPulse elements, the erase command to erase the content of the application log, the write timestamp command to write the timestamp data to the application log, and last but not least, the command write alarm to write the alarm number data to the application log. I trigger each command several times to fill the application log with some input. Now, since the application log has been filled with some information, I can go back to the already mentioned application log folder and click on the link Read Application Log. It is recommended to scan the system first to be sure to have an updated ECU list information. Via this link, the application log will be read from the flash memory and first writes data to an encrypted P1A file. P1, of course, stands for +1, and the A is for application data log. Second, with proper access rights, writes to a CSV, a comma-separated value file. If you still remember, the access rights has been defined inside the application log editor and guide. Another possibility to read the application log is available in the Service Tool menu File Read Application Log. The encrypted P1A file can be used to share with colleagues and protect against unauthorized use, for example. And via File Decode Application Log file, you are able to select an encrypted P1A file and save it as a decrypted CSV file. At this point, there might one limitation if you use the free version of PLUS+1 Service Tool, since the free version of Service Tool do not provide the access level to an application data log. To do so, or to use the AppLog with the free version, you have to add the component access AppLog enable to your guide code. Simple add this component somewhere in your code and connect a constant Boolean through signal to that component. Compile and download the LHX to your controller again. After I stored the files on my disk, I can open the decrypted application log, and we can see in the first 5 rows the default information of an application log. First, the title of the column, tag, access level, and text. The character set 65001 is a code page number for the character set table and refers to UTF-8, the Unicode. The node number, which is 29 in my example, and followed by the time key when the application has been compiled, which is also the time when the application log has been created on the flash memory. And the last default information is app ID, so-called application ID. The following rows are filled with information which has been defined in the application log editor and depending on the trigger input written to the log. Starting with the category error, statistic, and others, the assess level, in my example, assess level only 9, and the text including the signal value. So in my case, it is the timestamp for the first information entry and the alarm number for the second information entry, and so on. At the end of this video, I would like to jump back to the point where I mentioned the property save to file. As I already said, save to file is a property in newer HDDs which can be used to write the application log to an external storage via USB. My used hardware, the M1000, provides an USB host connection, and I will show in the following how to use that. First, I go to the guide drawing code and add a new trigger parameter to write the application log to a USB stick. Open the query dialog of the AppLog component and assign the new variable write to USB as an input signal. This input signal will be used inside the application log editor for the save to file property. That is all what is needed inside guide to set up the save to file or write to USB function. I added a new trigger parameter inside my service to page to trigger the write to a USB command, and the application log will be copied from the flash memory of the DM1000 and saved on the USB stick with the same name, same log data, and the same build in a CSV format. We hope that you found this tutorial useful. Remember that PLUS+1 community help is available on the PLUS+1 user forum. Check out other videos on our YouTube channel or contact the PLUS+1 Helpdesk. Thank you for your attention.